Greetings, folks. Welcome. In economic data analysis, we're often interested in the connection, or what we call the relationship, between two variables. Two of the most important concepts in economics are demand and supply. And when we think about demand and supply, this relationship between price and quantity is front and center. In a labor economics class, you might be interested in the factors that affect somebody's earnings, and one of the prime factors here would be somebody's education or their human capital. When we're looking at the relationship between two quantitative variables, we'll often make a scatter plot. A scatter plot shows one of the variables on the x-axis, this is the horizontal axis, and it shows a different quantitative variable on the y-axis, which is the vertical axis. So here's an example of a scatter plot. I've got my axes labeled, so you see the y variable and the x variable, and all of these points represent different observations. After making a scatter plot, you want to characterize the form, direction, and strength. So for form, the question is, can you picture a line passing through the points? If so, you'd say it has a linear form. For direction, once you've identified a linear form, the question is the line pointing up? If so, it's a positive relationship, or down, and that makes it a negative relationship. The third characteristic of a scatter plot that we're interested in is its strength. So if you have a linear form, the question is, are the points close to the line? If the points are close to the line, you have a strong relationship. If they're far removed from the line, it's a much weaker relationship. Here's an example of a scatter plot where the points actually follow a straight line. So here the relationship is as strong as it gets. Here's another scatter plot where these points really have no form, so the relationship is very weak. There are actually some statistics that we can calculate that give us a more precise idea of a relationship's direction and strength. The first is what we call the covariance. The covariance measures the linear relationship between two variables. If you get a positive value for the covariance, it tells us you have a positive relationship. And a negative value for the covariance tells us that we have a negative relationship between the two variables. Here's a formula that we use to calculate the covariance of a sample. So the notation we use is SXY. So the XY subscript reminds us that we have two variables. You see that it's a summation between I equals 1 to n. In other words, we do this for every single observation in the data set of xi minus x bar. So that tells you how far the observation is from the mean value for x, multiplied by yi minus y bar, which tells you how far the y variable is from the mean of y. You divide this by n minus 1. The formula is pretty similar to calculate the covariance of a population. We just use different notation that's consistent with a population. So here the notation is sigma subscript xy equals the summation of I equals 1 to capital N, because capital N means this is the population size. And it's xi minus mu sub x, where mu sub x stands for the mean of the population, multiplied by yi minus mu sub y. Again, that mu sub y represents the population mean value for the y variable, and this is divided by the size of the population, which is indicated by a capital N. A second statistic that we might use when we're studying the relationship between two variables is the correlation. The correlation measures the direction and strength of the relationship between two variables. The correlation ranges between -1 and 1. And values that are closer to either -1 or 1 indicate stronger relationships. The sign of the correlation tells you whether you have a positive or negative relationship. So if you have negative values for the correlation, it tells you have a negative relationship, whereas positive values for the correlation indicate a positive relationship. If you pull these two ideas together, if you have values that are close to +1, it tells you that it's a positive and strong relationship. If you have a value that's close to -1, it tells you that it's a negative relationship but strong, whereas values for the correlation that are closer to 0 tell you that it's a weak relationship. To calculate the correlation, which here is indicated by an R subscript xy, you take the covariance between x and y. We just saw that statistic a minute ago. And you divide that by the standard deviation of x, which is indicated by S sub x, multiplied by the standard deviation of y, which is S subscript y. Here's a formula for calculating a population correlation, which we indicate by rho. So rho subscript xy, again, this tells us that we have the correlation between x and y, equals the covariance of x and y, divided by the standard deviation of x multiplied by the standard deviation of y. So here we have a scatter plot where all the points follow a straight line, and sure enough, this gives us a correlation of +1. Again, it's a positive relationship because the points are moving in an upward direction, and it equals 1 because all the points follow a straight line. Here's a scatter plot where the correlation is 0.8. If you had a line that went through these points, it would be upward sloping, and the points would be fairly close to the line. Here's a scatter plot where the correlation is -0.66. So if you can picture a line going through those points, it would be downward sloping, and the points would be reasonably close to the line. Here's a scatter plot with a correlation of 0.43. So it would take a little bit of experience and maybe some imagination to picture a line going through these points. But if you did have a line going through these points, the line would be upward sloping, and again, that's consistent with the positive correlation. But in this case, if you could picture a straight line going through these points, the points would be pretty far removed from the line. And then finally, here's a scatter plot with a correlation of -0.06. So this is getting pretty close to 0. So for this scatter plot, it doesn't really have a linear form. In other words, it would be really hard to picture a line going through these points. When I calculate correlation statistics, I like to use the following rules of thumb to characterize the strength of the relationship. So if you have a value that's greater than 0.6, so this would be either in positive direction or a negative direction, you have what we'd call a strong correlation. If you have a value between 0.3 and 0.6, again, these could be positive or negative values, you'd say we have a moderate correlation. A value between 0.1 and 0.3, again, positive or negative, you'd say a weak correlation. If you have a value less than 0.1, either positive or negative, you would say that there's no correlation between the variables.